every meetup, we speak about some of the topics of Postgres. We speak about some of the use cases in Postgres, right? Case study in in any meetup will be a great addition, because that's exactly what people have done on the systems, on the customer delivery, right? And then experienced and have a ringside view of what exactly happened on the Postgres databases, right? So Brahmini is from OpenSource DB, and she's going to share a broad case study on how Postgres and DataLake, right, are integrated, and then how she and her team had sorted or solved one of the data lake problems, right? This is predominantly on AWS stack, right? Because that's the customer stack, right? So I'll let Brahmini speak more about it, and then Tarak would also be participating in this. So yeah, thank you so much for talking about this, Brahmini.
Thank you, sir. Thank you so much for this opportunity, actually. Myself, Brahmini. I'm working as a data engineer in OpenSource DB. And I'm here today to share my experience about the archiving the Postgres data on a data lake. First of all, we all know that as the data increases, collection and generation of the data increases, it has to be moved to a safe place for accessing purpose, or to store it in a secure way. So here we have chosen the data lake from AWS services as our client, as per our client requirement. They are adapted to the AWS services. So in this case study, we are going through some of the why we have chosen archiving the Postgres data, and bit introduction of data lake and architecture of it, and the unpacking of the data lake services. My colleague Tarak will take care of archiving.
And we have around 22 terabytes. The major mood of the customer is it's not an hot data. So there is 5 terabytes of my data. It's for the hot data, and it will be useful for the regular operations. Along with that, so there is a 17 TB which is used for the reporting purpose. So we kept those things in our mind, and we already implemented the table partition already. And so we implemented Partman along with an RPG cron, so where we schedule the partners in the logical application. And yeah, so as you guys know, so DDL is one of the challenges in logical that's there in the backend. And so we already been there, and we talk about the downside of those things, like so in terms of a cost perspective, in terms of handling the queries, in terms of tuning, in terms of optimizing. So we talk about the more discussion about that, and so we came across the conclusion and use separate the layer of an archive data, and then we put it into the somewhere else, so that it will be gives more effective, and it will be access to the users, business users for across the layers. So those layers and the architecture part will be talked about by Brahmini, and yeah. So thank you.
Coming to the announcement data lake. First of all, data lake is a centralized repository. We can store structured, unstructured, or semi-structured data in that, in its original format and in its original size. So first we have chosen the structured data for archiving, and then we'll create ingestion pipelines to move the source data into the data lake. Then and also another form of pipelines for client access of the data which is dumped into the data lake. Then we'll incorporate with the data catalog, which creates the scheme of the data, what we have ingested into the data lake. And for this, for all these to happen, we have to give some security and access controls provided by the client. By this, we will connect with the Postgres database for ingesting the data. And coming to the architecture, here is the architecture. Here you can see the flow of data from Postgres database into to the business analyst in a simple way by creating a unified look of the data from Postgres database into the data lake. They can access the data in an easy manner. So first step is the Postgres database. We have requested the client for creating the user and giving for controls for accessing their database for ingesting the data. And in the data lake, we have used the tools like AWS Glue, which gives the capability for integrating the data in the code, visual and coding interface. By this glue, the data is ingested into the data lake, and it is prepared for analytics purpose. Glue has a centralized repository, that is a data catalog, which consists of metadata and scheme of the data what we have ingested. The scheme of the data is created by the crawlers with the help of the classifiers in the crawlers. So the data, these catalog consists of the table schema of the data present, schema of the data present in the S3 bucket or source data also. And coming to the S3 bucket is the main fundamental storage of this data lake. Actually, we'll store all the data ingested from the source into the data lake. It is highly scalable service. We can provide, we can give some controls also who can ACLs and bucket policies. By using the bucket policies, we can give accesses and some management. We can manage the S3 bucket by like multi-region replication and some other services actually. So all the data present in the catalog scheme of the data helps the business analyst to query by using Athena in a simple way to access the data. And coming to QuickSight, it gives a visualization of the data in pie charts or graph diagrams. By this, we can make the data available for the business analyst. And
yes,
so
one point need to be handled because we
then coming, we have expanded the terms. Yes, sir. Coming to the unpacking of this case study, we have implemented the retention policies. These retention policies are based on the client and also user. As per the client, what are the security sensitive data to be stored, up to what extent, and how many, and based on the data types, we can store the data by using these policies. And it is also cost effective. Based on the cost also, we can store the data and some.
So this is the first point. So we bring the 22 terabytes of data from so we around in the 5.5, and so the backup strategy, right? So where we consume that prospective. So yeah, so table partitioning. So there is less table stable partitioning, and then leverage the logical replications aggregation as well. So these are the points, and then we decrease the RPO and then other stuff as well. So that is something we are packing these use cases basically.
How did you do the first one?
Yeah, so all the partitions will be stored in S3, so by using the blue jobs, and so Ethylon will be able to access those data from the S3 in a format.
You use the archiving there, compression or something that how the data set?
Yes, it is. Yes.
So, did you take impacts in performance also? Just cold data. Cold data.
Yes. So the hot data is in 5.5, so which is there in the current system.
What is there in the what is the cold data?
Yeah. So the highlighted blue data is an archive data, so where it is in a cold data, so where we transformed into an S3, and then we can accessible to the users.
You store the data in packet format?
Yes, it is.
So who is converting the data into JSON packet format?
So blue. Yes.
Blue is basically it's a ETL job.
Okay. So it will take care of that. So by helping the crawlers, so we have a crawler job using the JDBC connection drives in them, so it will be boom the data.
So you are reading from the source database
Right.
and then converting it.
And when we say cold data, the data is never querying from Postgres or occasionally it's querying.
Yes, it is. So it's in a reporting purpose, so where we use in a monthly basis and then weekly basis basically.
What I meant to ask was the data is never brought back to Postgres for querying that cold data.
Okay.
Instead of keeping it in the active servers, they know that this data is going to be cold and used only for reporting. They wrote this as architecture to move the data efficiently over the cost of the
So whenever you want
But
at some point you bring back the data back to
that's not pretty good.
you never bring it back.
We don't use it anymore. We don't use it anymore, or we will be. See, just that
Keeping the data is not
So then, if I summarize some of the questions that we have, the architecture is basically, now the hat of the engineer, who was behind this, right? Not an organizer, right? What we did, what we found when we are working with the customer is the amount of the dollar spending that is going into the super speed drives, right, and then the IOPS that AWS RDS requires, right? Basically, it's a costly affair, right? And then the amount of data we were talking about here is round about the volume of 17 terabytes to 22 terabytes, right? And the amount of data that the whole RDS engine, it's processing, right? That is adding to a lot of cost to the whole bargain, right? And then when we looked at some of the business use cases, right? And then we vetted out some of the reports that the customer is taking on a regular basis, on a weekly basis, on a specific frequency, right? So we worked with the business and then found out what is the exact amount of data that needs to be there on the production systems, right? On the production systems which are hosted on these the NVMe drives that we attach to RDS instances, right? So that basically we found out that somewhere around 6 terabytes, 5.5 to 6 terabytes on a monthly basis is what is actually required of the production system, right? So what we did is we created a logical replica of production, right? I know the font is slightly small. We called it as the archive logical replica, right? all that archive logical replica will hold is the bunch of tables which we are interested in archiving from production system to a long-term storage, right? And if you take a look at it, there were, our schema has got somewhere around 600 to 625 tables, right? Off of that, we picked and chose what exact are the, what are the tables that we wanted to have on archival, right? Like Rajesh spoke about the DDL, we also had a lot of nightmares in getting what DDLs are happening on production and then applying the same on logical and stuff, right? Once we know what are the target tables, right? Who are the contenders that we need to archive from one source, all across, right? Across this architecture. Then we found out AWS Glue, because the customer was a super AWS Pro user, right? And then, we figured out that AWS Glue is a, pretty straightforward, no nonsense, right? You just click and then, set up all of your ETL jobs, right? And then ETL crawler and data catalog is more of the metadata guys, right? Who takes care of what is coming into the archival system as a DDL change, right? And then all of the crawlers and data catalog will take care of this whole metadata management for us, right? And then once the Glue is performing the read from archive system and then converting all of these into pocket files, right? And then the pocket files are stored on the AWS S3 buckets, right? What we did on the S3 level is slightly, we went ahead, a step ahead and did created S3 buckets for each and every day, right? So we are storing data from 2014 onwards, right? And then we figured out what are all some of the queries that are being run, right? What type of reports that are being run. At some point of time, we figured out that yearly, monthly partitions and then yearly, monthly buckets were not giving us some satisfactory results, right? When we moved from getting the Parquet files and then classifying them and then storing them on a daily basis, and then AWS Athena has got a capability to just look at the Parquet files, simply write a SQL statement, right, which does not have any rocket science, right? And the business analysts are the guys who are looking for older data, right? They can just hop on the Amazon Athena, right? Write simple SQL queries and then pull whatever data that they are looking for, starting from 2014 to the data, right? And then from a cost perspective, Bharat had a point about, hey, how did you guys save such a good amount of money, right? It's more of how much of egress and ingress that we have negated out of the RDS system, right? That's one thing. And obviously, RDS does charge super heavily for some of the NVMe drives for us, right? And then the IOPS is also something that is a costly affair there, right? And the addition of QuickSight is another component, right? The AWS component, which is the one of the coolest visualization tools that we had come across, right? So it visualizes whatever the data that is available on Athena, right? And then the business analyst does not need to do this, does not have to change anything, right? As long as he can write he or she can write a SQL statement, he'll be able to do the same thing from AWS QuickSight, right? That's the whole passage of it, right? What we would like to also highlight here is, if you look at the yellow lines, right? So all of the data that is available on archive server, right? Because this is a logical replica, right? All of the data is real time, right? The entire gamut of data that we would want to have on archive server is a real time basis, right? Entire systems, entire transactions that are happening on production are also happening on archival because of the logical replication, right? So the business analyst can go back to 2014, go back to 2020, whatever the data set that they want, right? They'll be able to go ahead and formulate a holistic data retrieval, visualize it, and then do whatever with that particular data set. The entire stuff is automated. Yeah. Say ad hoc, what exactly do you mean by that?
You're running on a scheduled basis.
Yeah.
You run it.
So the crawler is the guy who helps us in figuring out at what point of time we would want to have the glue job running, right? We are doing it hourly basis. At the moment, we are doing it hourly basis, and then we are also working with the team to say, hey, why not do it 15 minutes, right? So that the data that the business analyst is looking is only 15 minutes old. Yes, yes, it's on entirely on Postgres. Now what we did is that 22TB is offloaded, and then that whole of data is available on archive server and the S3 buckets. Archive server is more of it's hooked up to S3 buckets and then converted as Glacier and stuff in some cases. But the archive server now has the latest and greatest available data, and then we are going back 3 years. Only the 3-year-old data is available in the archive server. If the business analyst is looking for older than 3 years, right? So he can go to the Athena, query the data, and then boom, you'll be able to see the report on QuickSight.
So this archive server is another RDS?
Another RDS server, yes. So currently it is not an RDS, right? We did a lot of hit from a cost perspective. So we built it on EC2, and then we are running it on a small storage, not so very costly storage, I would say. We have not. Our production is still on RDS.
But your actual primary RDS is
Yep. Yep. It's not 22 TB. It's 5.5 terabytes now. EC2 is on 22 terabytes now. So after the solution is implemented, guys, let's focus on the question. The end result of this, it's not an end result, it's a continuous result, right? So what we have done is the production database, which was a 22 terabyte now running on an RDS, is now a 5.5 terabyte database, and then the entire 17 odd TBs are pushed into S3 buckets or in the archive server. It is living somewhere in the world, right? So the 5.5 terabyte is the only database, the production database that is available on RDS now. On RDS, we did what? Cleanup, yeah. That's the archival process that we have done. So it's an online lottery gaming industry, right? So the transactions per second, the transactions per minute are super solid, right? Mm-hmm. They are both. That's one of the reasons why we have 3 months of data available in the production. So that itself is constituting of that 5.5 terabytes. Plain table data, right? Plain table data. No hanky-panky images, no media. Nope. So the question is, how did we move the, or why did we move? What, I didn't understand the question. So it was 22 terabytes. Now it is 5.5 terabytes. So we did DataLake plus data archiving plus some ETLs, and then moving to a long-term storage. That's the whole pathway. Yeah, in simple terms. And sorry for hijacking the case study talk, but any questions? I mean, there are far more reasons. Hari and team will talk about the cost aspect of it, right? I mean, of course, they don't decide how much of costing is involved and stuff, right? But yeah, it's a costly affair. When you are talking about 22 terabytes of data, and then you are adding round about, say, 230 GB of data on a daily basis, right? It tends to be a little costly. Yeah. Yes, please. So that's where partitioning helped us. So Abhi, what we are doing on production is we're storing only the last 3 months of data. Right? Production is holding only the last 3 months of data, and all the partitions, right? All the partitions older than 3 months are moved into archive server. Archive server will hold 3 years of data, right? That's from a South African compliance management standpoint, right? So we have archive data holding 3 years of data. Anything that is older than 3 years goes into S3 buckets as packet files. Month-wise partition. Sorry? Yeah, PG Partman.
So generally from production, you may not get very close to more than 8 months.
That's the business decision that we consciously took while working with the customer. Yeah. I mean, some customers might say, dude, I would like to have only 1 month of data. Or some guys will come up and say, I want to have 1 year of data. Right? So it's a pure business derivative and decision that you will work with business. Yeah. Sorry? Yeah, online lottery, online gaming industry. Yeah. So more of these are gaming industry, right? Now, the age of a game is less than 21 days, less than 15 days. Some of the games are not more than 45 days. So within the 45 days, the age of the transaction, right? Say, for example, you are betting on one game, one online lottery or one game, right? That age of your transaction does not go beyond 45 days. I mean, I can talk about the online gaming and lottery for a long time. I don't want to get into that. So what you are doing, what you are going to leverage from a compression, you will complement that while you are decompressing that file. So we did not want to do that. We wanted to have the Parquet files. Parquet files are very, very small footprint. So we did not bother about compression at all. The indexing is what will become a pain. We haven't come across that, as a matter of fact. Sorry? Yeah. That's why we often say, right, understand the problem, understand the data, and then understand the workload. 95% of your problem is done. Exactly. Right. That's the point he's trying to make. I do not have any control over what that guy does, right? One of the user will come up and say, I did play one game in 2016 May 5th, right? And then I want to know what are my winnings, how much did I deposit, what is my withdrawal, right? Yep.
busy clause, then again this would cost a bit high. So that's why my question was.
So the classification I would do from a business analyst standpoint is, because the guy already has access to archive server which is a logical replica, that guy is holding 3 years of data, right? The business analyst is smart ass, and then he'll go back and say, what is the exact data source I am going to go ahead and pull, right? Whether it's the Athena plus QuickSight, or I go back to the archive server. And most of the requests that we are, the business analyst is actually pinging and polling is, it gets subsided with the archive server itself, right? There are very few use cases, right? But from a compliance standpoint, when somebody is reconciling data, right, and then going back to the South African government and say, dude, this is the amount of business we did, this is the amount of reconciliation that we have been requested, and then they have to go ahead and have access to that data, right? That's why we build this whole solution together. Yeah. I mean, hospital data will have more and more data to play with, more types of data to play with, right? Guys, in the interest of time, and I'll close the case study discussion here. Thanks to Brahmini and Tarak for the beautiful work that they have done.